The simplest learning method I can think of is the nearest neighbor classifier. I'll show you how to implement it and use it for drawing recognition. We'll add our Sketchpad component to the data visualizer and extract features from it in real time. I'll also teach you how to visualize the classification process on our chart. To follow along, make sure you have the last version of the code. Take mine from GitHub if needed, and get ready for some classy coding. Get it? Because we're studying classification? No!
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
Let's organize these imports here in Viewer HTML. We have at the top this features object containing information about the samples and their features. Now here we have the common code with the Node.js scripts, the display part right here, and these ones below are for the chart. Let's add the new script where we include the Sketchpad. For the Sketchpad to work, we also need to include the draw.js file from common, and we'll use the Sketchpad as an input to draw something to be classified. I'm gonna go up here and prepare a container for it. Let's say input container, like so. And at the very bottom, I'm going to initialize a Sketchpad on the input container and save the file. Let's refresh, and there is our Sketchpad right here. And it works. This is the benefit of working with components. Now let's add some styles for it. I want it to float as well over the data next to the chart. In style CSS, I'm gonna go at the bottom and define here a style for input container, position fixed. I'm gonna give it 500 pixels from the right, that's how large the chart is, and 50% from the top, and we translate again, not on the horizontal axis, but by minus 50% vertically, so it's centered on the screen. To get that undo button in the middle, I'll set the text align to center. And let's give it also a margin of 10 pixels so it doesn't exactly touch the chart. Let's save this, refresh, and now it's here. And when we scroll, it stays in place. But it's blocking our data. I want to be able to hide it as well. So in Viewer HTML, we'll need to add a control panel. It's gonna be a div right here. And the button inside it, on click, will toggle the input, visible or not. Let's give it a name. And this toggle input function I'm going to implement in display.js. At the bottom right here, we will write toggle input if the input container display is none, then we need to set it to be visible. I'll set it to block. Otherwise, I will set it to none. Let's save this, refresh, and the button is here, and it works. But let's put it up here over the chart. There's a lot of empty space there. In style CSS, I'll add a style for our control panel, position it to fixed, right 0, top 0. I'm gonna give it the same width as the chart, just so it aligns well. And then text align to center, so it's gonna be in the middle of that 500 pixel area. And let's have it with the padding of 10 pixels. Refresh, and it's right here. Now I want when this input is here to somehow hide what's in the background. And I found a funny way to do this in Viewer HTML. Below the Sketchpad, right here, I'm going to give the canvas of the Sketchpad a style. Using CSS text, I'm going to append to its existing style. It already has some things there. An outline, 10 pixels, solid red for now. And it looks like this, but I'm going to make it really big. So really, really big, like this big. And refresh. You can see it's hiding everything there. And if we change the color to a transparent black, it's gonna look like this. And I think it's pretty nice. It's only like that when it's on. Now, when we draw something here, I want to immediately show the features on the chart. So we'll need that information here on update. Let's open the Sketchpad and add here a second parameter on update, which can be null. Let's store this callback function here as an attribute. And in our redraw method at the very end here, I'm going to check if this update callback exists and call it with all the paths. Let's save this. And now in Viewer HTML, we can pass here a function on drawing update, which I'm going to implement right here, what to do when the drawing updates with the paths. And what we have to do is extract the features in the same way we did in the feature extractor. Here in Node, feature extractor, we have this part right here where we're doing it. Let's paste it here. And let's just define this as a constant. And log it right here. Now, if we save the file and refresh the page, we're going to get an error here. Features get path count is not a function. And the problem is that we have two objects called features. This one here should be the one in common here. It has the feature functions. But it conflicts with the one from here. In JS objects, we also call features these samples that have also the feature values. Maybe this is not the best naming convention here, but I think we can actually rename this one to feature functions everywhere. So let's do it. Feature functions. Feature functions. Feature functions, feature functions. I will also rename the file to feature functions as well. And we have to fix it in the feature extractor. Feature functions, a rename symbol, feature functions, save the file, and finally in Viewer HTML, let's separately include now feature functions and replace this as well. Save the file, refresh the page, and you can see here 0, 0 because the Sketchpad is redrawing itself on the beginning and the paths are empty. So the path count is 0 and the point count is also 0. But if I'm going to start to draw something here, you can see the first number is the path count and the second number is the point count. How many points are being drawn? If I'm going to start another path, I have 2, and the point count is still going up. And so on. It also updates on undo. We're back to 0, 0. Now let's close some of these files right here. There are too many open right now. And these folders right here. Let's show this point on the chart next. And it's going to be a dynamic point that moves as we are drawing. This is not the standard component charts have, but we can add it to our own since we built it. Let's remove this log and say show dynamic point at this point location. Let's save this, and in chart.js I'm going to go just below the constructor and add here show dynamic point as a public method. Given a point, let's set an attribute to this value and redraw. Now this dynamic point is going to be here an attribute of the chart class. Initially it's going to be null, and to draw it we'll go in this draw method at the end just before drawing the axes. And if we have one of these dynamic points, we'll first have to get the pixel location of this data point. So we remap from the data bounds, that's how the features are represented, to the pixel bounds. And here we can draw this point using our draw point function from the graphics file. It's gonna be black for now. Let's save this, refresh, and there should be something at 0, 0, but this chart starts now at 1 and 10 because that's apparently the smallest value for the path count and the point count. We need to have at least one path to make it a drawing. So if we drag this, we should be able to see this dot right here that should be moving as we are drawing something. So when I'm going to start to draw, it should immediately jump to this 1 location for the path count. And then as the path grows, it's going to go up in this direction. Let's see. Yes. And now if I'm going to stop this path and create a new one, it's going to teleport to this right column here and continue going up from there. But it's not very visible here, and we can make it better. You see, before drawing the point in black here, I'm going to draw another point. The same location. And it's going to be a transparent white point with a very, very, very big size. Let's put here 10 million. I basically want, when I refresh, to see this point on top of this faded background. It's much more visible. And the value needs to be so big because the chart can be zoomed in. And I want that if you zoom in like this and then you go to some extreme corner, this region doesn't run out. So let's see now how it looks like when we are drawing. Much clearer what is happening there. Now if I'm going to press toggle input, it's still here and I want it gone. Above where we have our show dynamic input, I'm just going to copy it and write here hide dynamic input, where we're going to put dynamic point to null, and we don't need this parameter here. Let's save this, and in display.js, when the input container is made invisible, we also hide the dynamic point. Save, refresh, And now when we press toggle input, the data here becomes clear because that faded region goes away. But I want it to come back when I press this toggle input. Now it does appear again when we start drawing. So if we can get this Sketchpad to trigger an update, it's gonna work. Let's save this, and in Sketchpad.js, I'm gonna go here and implement the trigger update method where I just put this code from here. Like so. And since we have now this method, I'm going to write here trigger update so the logic doesn't change. Let's save this, refresh. Look at that point creeping in here. Very, very small movement. There's a long way to go to 15,000 points. Yeah, but it works. Now, before we start to talk about classification, we would need this data to look like something, to have a structure. And these features are just not very good. It looks really mixed in my opinion. So let's try to compute some other features. I'm gonna go to Common, Feature Functions, and let's calculate the width of the drawing. For that, I'm going to write a function called getWidth. Given the paths, we take out the points as we did in the getPointCount function. And now I'm going to focus just on the x coordinate by taking the 0th value of the point. To get the width of the drawing, we'll need the minimum and the maximum. The minimum can be found using the min function of the math library if we spread out this x array, and the same thing for the maximum, like so. And the width will just be the maximum minus the minimum, like this. And since we have the width, we can also get the height in a similar way. They are really easy to understand features and usually they work well. Let me just copy this, and this will be get height with the y here, taking out p of 1, and the y here and here. Now we're gonna need to extract these new features. So we'll have to go to node feature extractor and change this from the path count and point count to the width and height. Also, these names here need to be changed. In viewer HTML, we also need to change this. Because we need to change in so many places, we need to find a better way to restructure this so that we don't get confused. What we use for extracting, what we use for displaying, they should just point to the same resource. So going back in feature functions, I'm going to write here an object called inUse, which are the functions that will be in use. And I will also add their names here, how I want them to be referred to as. So the name width, and the function will be feature functions get width, the name height, feature functions get height. Notice we are not calling these functions here, we are just passing them into this object. Now let's save this, and in feature extractor.js, we can now take out those functions by looking at the feature functions in use and only focusing on the function from there. And to calculate this sample point, we can just do map. For each of these functions, we call the function on the paths, like this. Now we don't need this code from here. They do exactly the same, but now with the new functions we have in use. The code is also more general in the sense that you can pass any number of features, making this a multi-dimensional point. But I'll teach you about those later. Now let's save this file and regenerate the features. In my terminal, in the node directory, I will type node feature extractor. It will work also without the JS. And now in our dataset features, we should see new values for the width and height. And I think they're proper since our canvas is 400 pixels. Oh, but the feature names are not good. We have to handle these as well. We go to feature extractor JS, and here for the names, we just replace this with feature functions in use, and we take out the name from there. Save the file, regenerate the features. I just press up and enter here. And now the feature names are also correct. To get them to appear on the website as well, I'm gonna go to feature extractor JS and just copy these 2 lines of code. In viewer JS, right here. This will be just point, and we can remove this code. We don't need to worry about the feature names because we just read them from this file right here. Now let's save this, refresh, and there they are. Now our node scripts and the web page are in sync. And something is weird here, isn't it? Look at this one drawing, this one house. It has a width of 900 something. How can that be? Our canvas for drawing on the Sketchpad was 400 maximum. What is this place? Let's hide this input and... Aha, interesting. Erminio. Looks like this horizontal line somehow might extend out of the canvas. It's possible that on some devices, maybe if you make a quick line like that, it still records the point. I don't know. But interesting and common, I have to say. In general, when you collect data, you have to expect outliers like this. And I think there are more problems. Look, this height also goes beyond the 400, which I expected to be here. Let's have a look at this highest tree here. Okay, maybe let's not look at that tree. One next to it. Okay. So this is also above 400. Of course, when I'm drawing them here, I'm drawing them on a 400 by 400 canvas, but it looks like it might continue downwards like this. It's strange. Maybe some of you can help me figure out what's going on. There seems to be a clear border here, and I'm quite sure that this is the 400 mark, because I guess on most devices the app should work. Yeah, it's exactly on the 400 mark here. And the height, maximum height, also I believe it's here. Yeah. But it's actually very common for data to have problems. In fact, I'd be surprised if there were none. I've seen things like this all the time, like when working with location-based data, the most common issue there was to have coordinates switched, but only in parts of the data. Another thing was that people used positive values in the southern hemisphere. Maybe that's where they live and they had a different convention. Anyway, we have a few problematic samples and it's great. We'll get to see how they affect. Look at all these pencils. They're here because many people just draw pencils like a vertical line kind of thing, which is nice. And I'm quite sure that these here must be pencils drawn horizontally, like that. But there's even more structure here. Look at all these clocks in a line here. And I'm quite sure this happens because many people draw clocks to have a square aspect ratio. where the width is equal to the height. Guitars are also here, probably because people draw them kind of like the pencil, a vertical line, but a little bit wide because of this part. So they are similar to the pencil in a sense from their aspect ratio, but a little bit wider. A lot of trees appearing here as well. Nice, we can definitely work with this. Let's see if our input still works. For some reason that transparent overlay doesn't appear here. It appears when we're drawing, but not before. Let's debug real quick. I'm going to log here our point, save the file, refresh the page. It's minus infinity because you can't calculate the width and height of nothing. It's fine, it can be like this, not a problem. Now, the most basic way of doing classification, to figure out what this drawing is to extract its features and then have a look in the feature space, what's nearby. In this case, it's surrounded with trees, so maybe we just classify it as the same thing that is nearby it, that we learned from the data. So we need to find the nearest sample relative to this point. And we already have a function for that when we built the chart. In Math.js, we have here the getNearest, used to emphasize and select things on the chart. And it also uses this distance function, which is just the length of the hypotenuse in a triangle, using the Pythagorean theorem. So these are the two things that we need. And instead of making this code modular in a way that the chart and what we do next will use the same, I'm going to have a copy of it this time. It's because I want the chart to be its own component and have these functions here. So let's copy these in our utils at the end right here. This math is going to be utils, and we have to use it here as well and here as well. Otherwise, I think it's the same. Let's have a quick look and remember how these work. The getNearest function, given a location and a set of points, begins by initializing a minimum distance with the maximum possible number, and then it will return an index, the index of this point, not the point itself. We then loop through all of the points, take out the point like this, and calculate the distance from our given location to this point. Store it in D. If this is less than the minimum distance, we update this minimum distance because we found a better one. And we keep a note of the index. Finally, we return the index. Quite easy, just a minimum search pretty much. Let's save this, go back to our viewer, and here we can remove this logging, and instead of that, attempt to classify this, to get the label from the point. What is this drawing? And let's log this label. Our classify function, I'm going to write it below, right here, for now. And first we need to take out just the points from our samples. So I'm going to use map, from each sample, the point. Now let's get the nearest index using our getNearest function from utils, like this. And we can get the nearest sample from the samples at this index, like so, and we return the label from the sample. Let's save, refresh, and it already says car here for some reason. Let's try to draw something, maybe a pencil, because that's probably going to work. Yeah, I'm really great at drawing a pencil. But it seems to work. It says it's a pencil because our point is here next to these other pencils, and probably one of these is the closest. I think this one. We'll improve this chart to show the nearest neighbor soon, but first let's display this somewhere on screen. I'm gonna make a place for it here. Inside the input container, actually, I'm going to type an ID, predicted label container, and let's close this ID. I'm gonna give it a quick style in CSS. I want it to be white and relatively large, relatively positioned. Let's save this and go back to viewer HTML at the bottom here. Instead of logging it in the console, we are going to tell our predicted label container to set its inner HTML to a text. It will be like, is it concatenating with the label? Question mark. Make it a bit more funny. Refresh. Is it a car? It says car when nothing is drawn. But if we draw something, it says now a house. This is not really a house. I wanted to draw a clock. But okay, now it's a clock. Let's undo. Back to the house here. You can see it's quite sensitive. These features are definitely not enough to make it reliable. I mean, I can do here anything I want, and it's not going to change the classification or the aspect ratio. This object can be anything depending on what I draw inside. It just won't have a chance to classify it using these two features. But it's a start, and it kind of works. Try it out. A fish seems to work. Because there's another fish next to this one. Let's update the chart so it looks nicer next. I'm going to pass here to show dynamic point also the label, and in chart.js here, and this dynamic point will have both pieces of information now. It will have the point and the label. So in this draw method, we have to take out here the point and the label separately from this dynamic point. And I'm going to replace here with point like this. And instead of a black dot here, I'm going to draw it using an image, using the predicted label. So we take the style from the label, the image from that, and place it at the pixel location with the draw image function from our graphics toolkit. Let's save this, refresh, and now you can see the point changes its appearance depending on what we are drawing here. Apparently a fish. Let's make a line connecting to the nearest sample here. We could figure out what the nearest sample is here again, but we already have it here. So I'm going to return here the label and then also the nearest sample. A little bit redundant, but it's okay. And we need to make sure that here where we call classify, we take out both the label and the nearest sample, like this. And here in show dynamic point, we can pass the nearest sample as well. In chart.js, we can go up in the constructor and specify a field for this one, the nearest sample, set to null, and show dynamic point is gonna have it here as well, where we can set it to the nearest sample attribute we just created. Now, inside of this draw function, in between these two, we can type a new path. We don't have a function for drawing a line. We just have to move to with the context to the pixel location. And now we need to go to the nearest samples point, but in the pixel space. So we need to line to remap the point from the data bounds to the pixel bounds using the point from the nearest sample. And let's stroke. This is not really a standard component, and we're probably gonna change things soon anyway, so I'm not worried about the code too much. Let's save this, refresh. Let's draw a car this time. It's not a bicycle. And not a fish. But let's see why it's a fish. It's a fish because it's mapped to this fish right here. If it would have just a little bit more width, I think it's going to go next to this car right here. Let's see. Let's try to draw very small. Yeah, it's a car. Haha. But it's gonna turn to a house if we draw a little bit more. Let's see. Okay, it's the house. Now it's this fish. Let's try to get it to that car above there. Increase its height a little bit. Okay. Now let's get closer to this fish. Something's wrong. Can you see it? Let me make it bigger. Look at this. It claims this fish is the nearest sample. It can't be. This car is definitely closer, even this fish. There's nothing wrong with our nearest neighbor search. Our chart is just lying to us. Bad chart. It's because it's displaying the data to fit in this square aspect ratio here. The width is squished like this. And it gives the illusion that the car here is closer. But it's not in the data space. And this is where people start to get confused. They look at things like this and they don't understand why their machine learning methods work differently. Let's make our chart not squish or stretch the data, and you'll understand better. Here, where we get the minimum and maximum x and y, I'm going to calculate a delta on x as the difference, a delta on y as the difference, and I'm going to store the maximum of these two. And we'll recompute these maximum values here. For the right will be min x plus delta, and for the top will be min y plus delta, like this. Let's save this, refresh, and now our chart looks like this, with a lot of empty space here because the maximum delta, the one from the width, is applied on the height as well. And that's why most charts don't do this. We don't like empty space in general, so stretching is default functionality here. But it's very confusing if you don't normalize your data. Now, if I bring my drawing back here, ooh, and zoom in, we can see that this fish is indeed the closest, now that the squishing doesn't happen anymore. But some kind of squishing or stretching is usually applied on the data. And to understand why, let's try to visualize the path count and point count from previously. I'm going to go to feature functions here. Let's comment these out. and type here name path count. Feature functions get path count. And the second one, point count. Feature functions get point count. Save this. In our terminal, re-extract the features. And look at that. All our data is essentially on one line. This path count feature isn't treated equally at all. We basically have just one-dimensional data here. Let's zoom in and see this better. And let's try drawing something. This is now our 0, 0 point. It's classified as a fish according to these features now. And if I'm going to start drawing, I can see going up very quickly, increasing the point count. And now a little bit to the right when the path count increased. But to draw anything, you really generate a lot of points relative to the path count. And if we visualize the data as we did before, I'm gonna keep this other variant for reference, you will see that this path count has almost no effect on the classification. Let's save, refresh, and let's zoom in here to see what happens. You can see these columns appearing again when zooming because of the squishing. Now if I draw something, I'm going to jump to this column. And now the point goes up. See how those lines appear, claiming that is the nearest sample instead of this? It is the nearest sample if you look at the range of this x-axis compared to the y-axis. And as you are drawing, you constantly get those lines to different columns there because the path count just doesn't matter. But we want it to matter. In general, we want to even the playing ground. We want each of these features to have the same kind of significance. And that's why we need to do data scaling to make these two features comparable. Did you follow along? Great. Please like this video if you learned something today and share it with others so they can learn as well. And if you got stuck somewhere, ask and we'll figure it out. You can also take my version from GitHub and compare. The width and height we calculated today are actually those of the bounding box. But some of the drawings are tilted like this, and I think we'd get a better result if we calculate them some other way. Think you can do it? Try also visualizing these rotated bounding boxes. In that way you know your code is good. Share screenshots and your code with me, and I'll include my favorite version in a future video. Next time, I'll teach you about data scaling.